Okay, going over this Chapter 8, Chapter 9 test. First question, put 4 comma 2 pi over 3 into rectangular coordinates. So the first thing you gotta know is that x is equal to r cosine theta and y is equal to r sine theta, where this is r and that is theta. So then this becomes 4 cosine of 2 pi over 3, and this becomes r, which is 4 sine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2, and sine of 2 pi over 3 is radical 3 over 2. So this evaluates to negative 2, this evaluates to 2 radical 3, and there's your ordered pair in x and y coordinates, rectangular coordinates. So this one here is the reverse order. So r, we need to know, is equal to x squared plus y squared, and theta is equal to tangent inverse of y over x. But remember, we have to pay attention to the quadrant as well. 2, negative 2 is in the fourth quadrant. Okay, so that needs to be something we think about as we go through and do this. So r is going to be 2 squared plus negative 2 squared, and that's 4 plus 4, which is 8. So it's root 8. Tablet froze, there we go. Root 8, which is 2 radical 2. And then theta is going to be tangent inverse of negative 2 over 2, which is going to give me negative 45 degrees. Okay, which they want to leave in terms of pi, so this turns into negative pi over 4. Okay, so if you wrote it as 2 root 2 comma negative pi over 4, I gave you points for that, but most time when we have a negative theta, we like to make it positive, so we add 2 pi to that, and it gives us 7 pi over 4. So either of those I gave full credit for. This one here, express polar equation, r equals 2 sine theta as a rectangular equation using x and y. Here again, you need to know that x is equal to r cosine theta, y is equal to r sine theta, and r squared is equal to x squared plus y squared. Start with that. R equals 2 sine theta. Multiply both sides by r, so it becomes this. Okay, now r squared becomes x squared plus y squared. Equals to r sine theta. R sine theta is y, so we get that. That's all I was looking for. That's all you need to do there. Down here, plotting these points. Okay, 4 comma pi over 6. So I find, let me just move this. I find the pi over 6 angle, which is going to be this one here. Okay, 2 pi over 12. Then I go up to the fourth circle. So there's A. B is at 4 comma negative 23 pi over 4. I don't like negative 23 pi over 4, so I'm going to start adding 8 pi over 4 to that. And basically, if I do that 3 times, it will turn this point into 4 comma 24 pi over 4 minus 23 pi over 4 becomes pi over 4. And that's the point that I'm going to graph. So 4 comma pi over 4 would be right there. That's point B. And then C is negative 4 comma negative 3 pi over 4. Again, however you want to do that. If you want to turn that into a positive angle, so add 8 pi over 4 to it, so it becomes negative 4 comma 5 pi over 4. And then go out to the 5 pi over 4 angle, which is going to be this one here. And this is 5 pi over 4. You go to the fourth circle, but because it's negative radius, you are then going to go opposite. So it's going to put C right there on top of B. If you're a person that prefers to just look at, negative 3 pi over 4 and negative 3 pi over 4 is that angle there, and then go opposite. That's fine, but B and C end up being the same point. Each one of those questions was worth, or each one of those parts was worth like a 1 1/3, I believe. Okay. or sorry, 1 and 2/3 points per one of those. Number 5, writing complex number in polar form. So here again, just kind of think about what this is, and I didn't see too many pictures drawn of this, which is going to be problematic if you don't think about a picture. Maybe that's -1, maybe that's √3. So we're looking at that point right there as being your complex number, maybe call it Z. It's in the second quadrant, so think about your angle. It's going to be bigger than 90 degrees. It's going to be less than 180. So think about that as we come up with some information here. Complex number, so I need the radius. So R is going to equal square root. That's A squared plus B squared. A being -1 in this case, and B being √3. So that's going to give me 1 there, 3 there, add those together, I get 4, so we get 2 as my R. Now I gotta find theta, and that's tangent inverse of B over A in this case, B being √3, A being -1. Okay, so when I evaluate that, it gives me -60 degrees, or -pi/3. Okay, but think about this. That is not in the second quadrant, so I cannot say that my answer is 2 cis -pi/3 or -60 degrees. Okay, because it doesn't get me to that location. 60 degrees is that angle there. So this angle is also 60 degrees. Thus, the theta that I'm looking for would be from here up to there, which hopefully you see is 120 degrees. So what I'm looking for here is 2 cis of 120, or 2 cis 2pi/3. I'm seeing a couple people type in 2, 2pi/3. That is not how we write a complex number in polar form. Okay, polar form has to use the cis information. Okay, let's go down to this one. This one kind of frustrated me a little bit. All we're going to do here is Z1, Z2, Z1, Z2. You multiply your R's, so we get 2 times 5. We write cis, and we add our thetas. Okay, so it gives me 10 cis. Okay, pi/4 plus pi/3. Common denominator, guys, is going to be 12. So it becomes 7pi/12. Okay. The next part, and I didn't do all or none here. I kind of gave points based on a couple things here for this question. When I evaluate, so what this means here is 10 cosine of 7pi/12 plus 10 I sine of 7pi/12. All I wanted you to do is grab your calculator and type that in, and that's going to give you -2.588 plus 9.659 I. Okay, now I gave 3 points if you had that. I gave 3 points if you wrote it this way, which I don't know that we would ever write this way. It's really not common. But if you put it that way, I gave you 3 points. If you just wrote it this way, I only gave you 2 points because you're not telling me that you know this is a complex number. So I need to see somehow that you had that I there. I'd prefer this. This is the way we write that rectangular form, but I knew what you meant if you wrote this with an I there. This one here, this is de Moivre's theorem, so we're looking for, again, a picture here is going to be useful. 4 radical 3 plus 4i, so that's going to be maybe a point here where that's 4, and this is 4√3. So I'm trying to cube that. Hopefully you realize then this is going to be a pretty large set of values. But to find r, we need to take 4 radical 3, we square that, and 4, and we square that. So it's the same thing as r is equal to square root of a squared plus b squared, which we did earlier in, I think, question 5. So this becomes 4 squared is 16, times radical 3 squared is 3, plus 16. That's all underneath the root. So that gives me, think about it, 16 times 4 as well. Another way you can rewrite that, the reason I write that way is because square root of 16 is 4. Square root of 4 is 2, so that makes 8. So r is equal to 8. Now, De Moivre's also incorporates theta, so we say tangent inverse of b over a. Well, b here is 4, so tangent inverse of 4 over a, which is 4 root 3. That is giving me tangent inverse of, if I evaluate it, radical 3 over 3, and that one is the 30 degrees. A lot of people had 60 degrees here. So now, De Moivre says z to the third will equal r to the third cis n, which is 3, times theta, which is 30. So now I get r to the third is 512. It'd be cis now of 90 degrees. See, a lot of people evaluate the cosine of 30 and then multiplying that by 3. You don't do it that way. Order of operations says you can't do it that way. So this gives me 512 cosine of 90 plus 512i sine of 90. Cosine of 90, that goes away, that's 0. Sine of 90 is 1, so this leaves me 512i. Number 8. Okay, these are just adding these things together and subtracting them. So this one gives me negative 2, 2. U minus V is 6, negative 8. And this one here, I got to multiply this one by 3 and then add W to it. So that turns into 11, negative 11. I don't think too many people got any of those wrong. But now this one here, remember what this notation means, magnitude. So it's length. So we're taking, remember, the magnitude of u is equal to square root of the a component, the first component, squared plus the second component squared. So here, we've got u minus v, which is this. We're going to apply the Pythagorean theorem to that. So 6 squared plus negative 8 squared gives you 100. So that is 10. Saw people having 10 and then did this. Put that around there. That's not right because that says it's a vector. We just want a scalar. It's just a magnitude. It's just one distance. Number 9 should be pretty straightforward. Magnitude of V is 40. Theta is 30. I'm asking you to write in terms of I and J. So we have the formula that says vector V in terms of I and J is magnitude cosine theta plus, or times I then eventually, plus magnitude sine of theta times J. So magnitude is 40, cosine of 30 times I, plus then 40 sine of 30 times J. Now we evaluate. Cosine of 30 is a half. Or sorry, cosine of 30 is radical 3 over 2. And then sine of 30, that is 1/2. And a lot of people are messing those up at this point in the course, guys. If we're messing that up, we've got a lot of issues. This evaluates to 20 radical 3 I plus 20 J. Now, writing in terms of I and J, I'd prefer that you write it that way. I did see some people doing this, 20 radical 3, comma 20. That's not a huge deal because that's how we write that vector in that component form. But I think it's a little bit more obvious if we see it with the I's and J's. But nonetheless, that's how you would do that. Now, if you could do that, which a lot of people did and got it right, as one of the most common questions to get right on this, but then a lot of people left this one blank and didn't do anything, which again is frustrating because you had the test the day before, so it shouldn't have been a surprise that this was going to be presented to you. But we're going to do the same thing. So I'm going to find vector v. I'm just going to use, so it's 4 cosine of 45 times I plus 4 sine of 45 times j. That's taking this information and plugging it into magnitude times cosine of theta I plus magnitude sine of theta times j. That turns into, so 4, obviously radical 2 over 2 times I plus 4 radical 2 over 2 times j. So this becomes 2 radical 2I plus 2 radical 2j. So that's nice, we got that. We do the same thing with u then. Okay, so u's information was 6 was the magnitude, and I was looking at 210 degrees. And this is where a lot of people made mistakes because we're not paying attention to the sign, the SIGN of these things in at 210 degrees. So 6 cosine of 210 is negative root 3 over 2. Sine of 210 is negative 1/2. So this becomes negative 3 radical 3I minus 3j. Okay, so those are u and v. So magnitude of u plus v, or I guess not magnitude yet, but u plus v should be this in component form plus that in component form. So we add together the 2 radical 2I and the negative 3 radical 3I. Okay, so we can write this way. That's I. And then if you, I'm not gonna put the I on there. Which 2 radical 2 minus 3 radical 3. And then the j's would be 2 radical 2 minus 3. Now I asked for the magnitude. So the magnitude, remember, of u plus v is going to be this number squared plus that number squared, and you take the square root of that. Okay, because this right here, so I'm going to put this as a decimal just to explain it a little bit better. 3.677, and this one turns into negative 1.716. Alright, so what's going on here, guys, picture-wise, is that we've got some vector v, which is maybe that vector right there. So that's v. Okay, 45 degrees and a length of 4 should be in the first quadrant. We have a vector u, length of 6 and 210 degrees. So that would be maybe here. So that's u. So u plus v, what we're finding out now, u plus v is going to be negative 2.36. This is minus 0.11716. That's negative, and that is negative. So what that tells me is u plus v is down here in the third quadrant. Okay, so adding these two vectors together gets me this blue vector. So it's a third quadrant vector. That's something very important to think about. Okay, u plus v is in the third quadrant. Okay, so now in order to find the magnitude of v, u plus v, it is equal to the square root of negative 2.3677 squared plus negative 0.1716 squared. A lot of people aren't putting parentheses around their negatives here, and we square it. That messes everything up. So now this is always going to be a positive number. That's always going to be a positive number. And when we do that, it gives me that magnitude to be 2.3739. So that is the magnitude of u plus v. Now I need to find theta. Okay, so finding theta. Okay, this is my x's and y's for my components, from i's and j's. So all we do is we take that one divided by that one. Okay, so you go tangent inverse of negative 0.1716 divided by negative 2.3677, and that should give us theta, which if we calculate that, it gives us 4.145 degrees. Now, if you think about that, something with a theta of 4.145 degrees is going to be in the first quadrant. We know our u plus v should be in the the third quadrant. So what do I need to do with that 4.145? That 4.145 is that angle right there. So I need to add 180 degrees to it, and now I get my direction of u plus v to be 184.145. Okay, so magnitude 2.3739, direction 184.145.